In 5, 4, 3, 2. And guess what, kids? It's pre-calculus with the live studio audience. Okay. And now today we start a brand new section, 9-1.
Rotation.
If you want to be good at this section, here's where it starts right now. All right? Start today. And as a matter of fact, no booze in the studio audience now. We're on campus. Oh, okay. Anyways, Steve. It's always. Okay. All right. On your notes, put down rotational velocity. That will be the title of the talk. All right. We'll actually take a brief walk through music recording history today. All right. Some of your fun facts here. All right. And for the buzzword, which you can just put on the very back where it's blank there, see if you can figure out how long it takes to drive 150 miles at 60 miles per hour. So you remember a very simple formula that involves things like distance and rate. See if we can figure out how long it would take to do that. In the meantime, I'll put this simple on board. And let's see who has the correct answer. A little Jeopardy music here. Fast forward if you want to at this point. All right, let's see. Anybody know what the formula is, by the way? Distance equals rate times time. Remember that old classic formula from middle school? Or maybe high school? Elementary school? Somewhere? All right, distance equals rate. Well, it's really important, all right? So know that point. Distance equals rate times time. So it says that we want to drive 150 miles, which would be your distance. And we're driving 60 miles per hour, which would be our rate. And by the way, a little side note here, you probably learned this in science class. Miles per hour is actually miles divided by, because per is like division. Okay, you did that before? Miles per hour is miles divided by hours. Okay, miles out of hours. All right, so remember that for today. Okay, and then to get time, couldn't you just divide both sides by 60? Okay. Anybody get it, by the way? Anybody get a final answer? Yes, 2.5. Yeah, maybe 2.5 hours? Yes. Nice, all right. Okay. And you know what? Here's even better. When you divide both sides by 60, the 60 goes down here, doesn't it? And even better, the miles over hours when you divide the other side actually flips over and gives you hours over miles, and the miles cancel. And you actually get it in terms of hours. Makes sense? And then, of course, if you just cancel a pair of zeros here, 15 over 6 turns out to be 2.5 hours. There you go. Interesting. All right, so remember that distance equals rate times time. And think about these canceling units, because we'll do that today. Okay, now, the first one, we have the group, the Beatles, which some of you may have heard of. Okay. Yeah. It's a matter of time. 20 years from now, we're just saying, who, what? All right. And the album title was also the Beatles, their self-titled album. This was the #1 Beatles selling album of all time. They had a bunch of big sellers, but this was #1.
Did they call it the White Album?
Perhaps you know it as the White Album, exactly. It's just like a white cover, and then the Beatles right there. Very nice. Okay, it was released in 1968. However, it is most notable in the world of music recording as being the first album ever released as a, okay, way before that, way before the world of
Record.
Okay, now records go back to like the 1800s. They go way back, surprisingly.
Cassette.
You know how we used to listen to music when I was a kid in the 70s? And I'm sure your parents are about the same age as me. Remember the old 8-tracks? Have you ever seen an 8-track before? That's like way old school.
My dad has a converter.
Oh, nice. The old 8-tracks. The 8-tracks were gigantic. They were like almost the size of this piece of paper right here. And you can see there's a picture down there. I have a nice color version up here. You can see that there's a picture down there of where it was inserted into the console. Right? I remember this like vaguely as a 5, 6, 7-year-old. And all the cars had this, and you just crammed the 8-track in there. And you couldn't fast forward it, you couldn't rewind it, you just displayed. Went through all the songs. If you didn't like the song, you just had to go through it.
Oh.
You can take it out, put it right back in, starts up right where it left off. This goes all the way through. Okay? Yeah. All right. I think they may have come out with some where you can actually rewind, but at first they just played straight through. And that was it. Endless loop. Very boring. It would just go on a continuous loop
Oh.
all the way through. On this little reel, you can see the inside of it right here. All right. So that's the 8-track. Now, you may want to remember this in the future, because if we don't have too many snow days, we can use one of those free days, built-in days, as game show. And it'll be like multiple choice. You guys have buzzers. All right.
Or you could have a party.
No, bad idea.
No, that would be hard.
Okay. Yes, it would be a party. It'd be a lot of fun.
Can I bring in food?
So, if you say, and I'll be Alex Trebek over here, okay? I'm Alex Trebek, and if you say, I'm Mr. Trebek, I would like potpourri for $200, please. If one of the questions says, what was the first album released on 8-track with a multiple choice? If you remember the Beatles, you can get it right. Okay? So be ready. Be ready for the fun. Okay, now this next one is the Go-Go's. Perhaps some of you have watched the Chevy Chase 80s movie entitled Vacation. Anybody? National Lampoon's Vacation? And the theme song of the whole show on TV all the time. And the theme song throughout the entire movie is this song, Vacation by the Go-Go's. And the unique part about this is that in 1982, it was the first song ever released on the CDs are still way back there. Cassette tape. Okay. And when we were seniors in high school in 1988, I mean 98, not that old. When we were seniors in high school in the 80s, as were some of your parents probably, that's all we had, cassette tapes and records like this. Okay? No fancy schmancy CDs, all right? Everybody had cassette tapes. And at least you could rewind and fast forward them, but of course if you wanted to find your favorite song, it was like the fourth song on the album, you had to fast forward it, play, and it's still in the second song. Okay, play, and that's the third song. Okay, play, and it's still in the third song. Okay, now we're in the fourth song, but I missed half the song. Okay, rewind, go back. Okay, you kids can't appreciate those days, but it was pain. All right, but we didn't know any better. We said, hey, this is great. Okay, so that's a cassette tape. Now, remember that's the future. All right, on the 8-track cassette, you can see the insides here. You've got a 9-centimeter diameter, and this wheel will rotate at 1 revolution every roughly 3 seconds to get all the way around. Okay? We're going to figure out what the rotational velocity is. How fast is it going around? Okay? All right, so let's do this first. Remember that distance equals what? Rate times time. Now today we're focusing on rate, kind of like we did over there. Okay? Although I guess we were given rate with amount of time. So this time we're going to focus on rate. If distance equals rate times time, what does rate equal from this equation here? Okay, distance divided by time. Okay, so we're going to concentrate on rate today. How fast does it take for things to move? All right, so let's try it. Now, here's the key today. The key is figuring out how far it is all the way around the circle. And if you want to know the distance all the way around a circle, that would be called the what? Circumference. Good. What is the circumference formula for a circle?
2 pi r.
You can do 2 pi times radius.
Or pi times diameter.
If you have 2 radii, that's the same thing as a diameter. So you can actually do d pi as well. Okay? So either one of those works. All right? So we're going to use this. Tell you what, let's go ahead and find the circumference of this 8-track wheel in here that's rolling around. All right? So let's see. The diameter is 9 centimeters.
No.
So if you plug that in, should be 9 pi. And the units would be what? Centimeters. So there's your circumference. Okay? But we're trying to figure out how fast is it going around. All right? Let's look at the revolution right here. It makes 1 revolution in 3 seconds. That would be like saying it makes 1 revolution
Every 9 centimeters.
per 3 seconds. Isn't that kind of like that? If it's per 3 seconds, you know what that is? It is what mathematical operation? Division. Isn't 1 revolution in 3 seconds the same thing as 1 revolution over 3 seconds? Because it's per 3 seconds. Okay? So you set it up as a fraction. Now we can use it mathematically, because those are just words. Now it's math. Right here. Okay? So let's try that. Now, here's the key. A revolution. Isn't a revolution the distance that you would travel all the way around? So a revolution is a what for a circle? It's a circumference. It's the same thing. So you can replace the word revolution with the circumference. Same thing. Okay? So it's going to do 1 circumference every 3 seconds. And that is going to be 9 pi, one single 9 pi, and what are the centimeters? Every 3 seconds. And you can easily reduce that. 9 pi over 3 is 3 pi. And you can see the units, what are the units right there? Centimeters per second. There you go. Okay. And it does say to leave your answer in terms of pi, which means